Today we will be discussing about the nanotechnology. The father of nanotechnology was physicist Richard Feynman. The idea and concepts of nanoscience and nanotechnology started with the talk, "There's a plenty of room at the bottom" at the California Institute of Technology, or Caltech. Long before ago, the term nanotechnology was used in his talk. Feynman described a process in which scientists would be able to manipulate and control individual atoms. Over a decade later, Professor Norio Taniguchi coined the term nanotechnology. It wasn't until 1981, with the development of the scanning paneling microscope that could see individual atoms, that modern nanotechnology began.
Nanotechnology in everyday materials and processes. Many benefits of nanotechnology depend on the fact that it is possible to tailor the structures of materials at extremely small scales to achieve specific properties, thus greatly extending the materials science toolkit. Using nanotechnology, materials can effectively be made stronger, lighter, more durable, more reactive, more sieve-like, or better electrical conductors, among many other traits. Electronics and IT applications. Nanotechnology has greatly contributed to major advances in computing and electronics, leading to faster, smaller, and more portable systems that can manage and store larger and larger amounts of information. Nanotechnology in medical and healthcare applications. Nanotechnology is already broadening the medical tools, knowledge, and therapies currently available to clinicians. Nanomedicine, the application of nanotechnology in medicine, draws on the natural scale of biological phenomena to produce precise solutions for disease prevention, diagnosis, and treatment. Nanotechnology in energy applications. Nanotechnology is finding application in traditional energy sources and is greatly enhancing alternative energy approaches to help meet the world's increasing energy demands. Many scientists are looking into ways to develop clean, affordable, and renewable energy sources, along with means to reduce energy consumption and lessen toxicity burdens on the environment. Nanotechnology in environmental remediation. In addition to the ways that nanotechnology can help improve energy efficiency, there are also many ways that it can help detect and clean up environmental contaminants. Nanotechnology could help meet the need for affordable, clean drinking water through rapid, low-cost detection and treatment of impurities in water. Engineers have developed a thin film membrane with nanopores for energy-efficient desalination. This molybdenum disulfide membrane filtered 2 to 5 times more water than current conventional filters. Nanoparticles are being developed to clean industrial water pollutants in groundwater through chemical reaction that render the pollutants harmless. The process would cost less than methods that require pumping the water out of the ground for treatment. Nanotechnology in transportation benefits. Nanotechnology offers the promise of developing multifunctional materials that will contribute to building and maintaining lighter, safer, smarter, and more efficient vehicles, aircraft, spacecraft, and ships. In addition, nanotechnology offers various means to improve the transportation infrastructure.
What are the challenges of nanotechnology? The most pressing issues in nanotechnology is gaining a better understanding of materials and their behavior at the nanoscale. Universities and business across the world are exploring how atoms interact to produce larger things. We're still learning how quantum mechanics affects substances at the nanoscale, and because elements behave differently at the nanoscale than they do in their bulk form. Some nanoparticles may be dangerous. Some experts are concerned that because the nanoparticles are so small, they could easily pass through the blood-brain barrier. which protects the brain from dangerous chemicals in the bloodstream. We need to know the nanoparticles won't poison us if we're going to use them coat everything from our parallel to our highways. Here are the other challenges in nanotechnology. With the advancement of technology and communication, there is a concern about privacy. As medical technology advances, the death rate will decrease, resulting in a rise in population and a food shortage. Environmental issues, as nano-industry waste is difficult to degrade. Strong pesticides and insecticides are required for genetically modified crops. Fear of biological weapons may increase as a result of nanotechnology.
Nanotechnology is a rapidly developing area in science involved with manipulating matter at the atomic or molecular level. Nanotechnology is typically defined at a scale on the order of less than approximately 100 nm. Matter possesses unique properties at these size levels that are neither Newtonian nor quantum, but between the two regimes. These unique properties have created significant interest and excitement, sparking numerous research investigations. Nanotechnology is a very broad field with many current and potential applications. Some important examples of application include battlefield activated dynamic armor clothing for soldiers, additive to sunscreens, and diagnostic laboratories on a chip to monitor general personal health. Groundbreaking capabilities often raise new questions. Any new scientific or technological development has the usual concomitant associated ethical issues, specifically regarding containment and regulation. These ethical issues are more pronounced with nanotechnology due to sharp divide between those who see its great potential and opponents who express fears. Nanotechnology supporters believe that it has the potential to transform our lives dramatically, while opponents of nanotechnology fear that self-replicating nanobots could escape from laboratories and reduce all life on Earth to gray go. These fears have swayed generally uninformed public opinions via the media and sensational entertainment. A critical discussion of ethical issues surrounding nanotechnology, including the interaction of nanotechnology with the body and the environment, nanobiotechnology, and regulation of nanotechnology, is presented. We advocate strong uniform regulation for nanotechnology, but only the use of regulation as needed. The limited use of regulation prevents the regulation from becoming burdensome and inhibiting research in the field.
Nanotechnology could lead to significant developments in medicine, computers, and other areas. It will likely be important to the future as well, thanks to its efficiency and ability to do things that we normally can't with current technology. However, as useful and beneficial this tech be to humanity, it can still bring potential and significant health hazards. Because nanotechnology is still new and many developments are needed for it to be properly used, there are still many questions about the risks that it carries. The miniature size of nanomaterials and how they were made. The very characteristic that made them excellent to apply in medicine and other fields, make nanomaterials potentially dangerous to humans and the environment. Nanomaterials can be inhaled, which can cause inflammation or damage to the lungs because of their ultra-fine properties, which can go deep into the lungs, and it can also carry other harmful chemicals with it. The nanoparticles can also enter through the skin and even through the digestive system, which can damage cells or enter the bloodstream. It might cause damage to the brain. The human body has and can develop tolerance to most substances that come in contact with it, but it might not have any natural immunity to new substances like nanoparticles, and the body can find it very toxic. In some cases, it can suppress the immune system by affecting the function of T cells, which is a type of white blood cell that fights infections.